Hello everyone. Welcome to my coronavirus prediction video. And today I'm going to be doing some prediction on the coronavirus and what it will probably be doing in the 14 days of our quarantine in Malaysia. So here we go. I have made this. Oh, how do I remove this thing? Okay, just drag it down here. So for your information, I've been using this Wikipedia page, which is fairly up to date. Look at this. It has the newest information available since the 24th of January and up to today. So yeah, it's pretty good. And I'm going to be doing this prediction in Excel because I'm the most familiar with its analytical language, but I'm not really that good at it either. So the main impetus for me to do this video is this thing that's been circulating around in WhatsApp. I'm sorry if I'm a bit quiet because I don't want my brother and my sister-in-law to wake up. They're in the next room, so yeah, you'll have to put up with ASMR awang. I think that broke the mic. Okay. Anyways, COVID-19, Malaysia would ban casing game. Just fill in the blanks. Okay, so yeah, you can see here some correlation. It's the same amount of proof, and if you continue, you see it here. It's 900. Oh, just let's see the actual data here. I have actually done some filling in of the data myself, and here I've put in the real data, the simplified version, but not up to 21 and 22nd, the 21st and 22nd, because I actually wanted to do this video since the 20th, but yeah, you could say I've been slacking. Let's just do that for now. Yeah, 310. All right, so we have the real data here, the simplified version, and the model, which is what we're going to be doing now. So for the model, the first one, we just want it to be equal to I6. Yeah, but then we want a growth rate of around 2.5 persons in 5 days. So if you divide 2.5 by 5, you get about half. I don't know. Let's just see. Let's give half right there. So in the second day, this is the initial infection rate when there's no quarantine or anything. So let's see how much it can grow. So for 200, for the next one, let's have this number, the initial number, plus the initial infection rate times the initial number here, and so we'll see what happens. Okay, so it's not that far-fetched, but 60 plus people is not accounted for in the model. Let's just see what happens if we drag it out down here. Oh, I mean, how do you do this? I forget. Hmm. M5. Maybe I need to drag M5 down here. Nah, wait. Eh, way down here just for safety's sake. Yeah. No, wait. Okay. So let's see what happens. Yeah. Okay, that's what missing. Yeah. It doesn't have any value down here, so that's why it was missing. And yeah, I messed up there. Ah, come on. Okay. So yeah, now we have 300 to 450. Still pretty reasonable. 675. Yeah, big jump, but let's see. Oof, okay. Now we have a half person being infected on day 5. So yeah, you can see if there was nothing done at the initial infection rate with 200 initial people being infected, we would have gotten about come on. I'm sorry. Yeah, 295,578 people. And continuing on with that term until down here, let me see. Yeah, okay, that's why. Let's see how long it would take to infect everyone in Malaysia. Let's just see here. Oh yeah, okay, so you need that definitely infects everyone in Malaysia. Well, actually, you just need around here, yeah. So on the 12th of April, if there was nothing done, since there were only 200 people. Oh wait, I need to check my phone for recording. Yeah, okay, it's still recording my audio. So for an initial number of 200 people and no change in the spread rate, will get everyone in Malaysia infected by the 12th of April. And you know, that's not that far off. It's just about, I don't know, I don't know how to count number of columns. That's fine, but it's not that far off. I think 1, 2, 3, 4, 5, 6, 7 a week, and then you have 2 weeks, and then 2 weeks here. Yeah, that's 3 weeks. 3 weeks from now, if there were no control order, movement control order, we would have everyone in Malaysia infected by it, and with the current mortality rate, which is about zero, I think about 30. Yeah, just give 30% of people dying from there. Let's see, 0.3. We see here 0.3 times number of people infected on the 12th of April. We'd get about 1115. Yeah, you see that number of people dead. So yeah, it's a pretty serious thing. We should not be looking at lightly. Now there's about 11 million. Oh, oh yeah. I think that's a bit wrong, isn't it? That's a third of people. Oh, okay, yeah, okay. D37 times J36. Yeah, okay, wait. Let me see here. 0. Yeah, a million people. A million people would have died if only 3% of people dies. So yeah, serious thing. And the worst part of it is that it's not a choice. If you get it, you're pretty much dead. If you're old or you have a pre-existing condition, and the real danger of the coronavirus is not that it kills so much, but it infects people so quickly, and obviously, yeah, we should try to stop the spread of this virus, and we are trying. And yeah, this is not actually this growth chart is not actually very realistic because we now have the movement control letter. So let's try a little difference in our experiment here. With the initial infection rate of 0.5, it's not really changing every day. That's kind of an issue, isn't it? So let's try to, you know, reduce it by 0. Just tiny amount, 0.05. Nah, 0.005. Yeah, 0.005. A tiny amount of change, and let's actually just see what would happen in those. I think we should see up to here. Yeah, what would really happen if there were no control if there were control movement order on the 12th of April. So with the control movement order, we say around 18 March. So here we should say that instead of 0.5, it's whatever is on the above cell minus this cell, and so you get 0.495. And to make the formula work, I just drag this down here. Oof, okay. Yeah, forgot about that. Okay, it's the same amount of reduction every day with the movement controller reducing the amount of people. We'll just see how much it slows down. So here we go. Yeah, 0.05, 0.038, 9,937,199 people. Oh, come on. Just so yeah, from everyone being infected with just a reduction of 0.05, which is a minimal control movement order, we get a reduction of about 20 million people not getting the infection and only 400,000 people dying, which is a lot, but it's not 1 million people dying. So yeah, we need to stay in our houses, guys. Just don't go out. And the problem with the coronavirus is it's not that it's killing fast. It's not the virus itself that kills. It's actually the virus attacking your lungs inner walls. Again, I'm not a medical authority. I'm just an engineering student with a little inclination in science, and he knows how to use Excel Yeah, I know how to use Excel, but not that much, as you can see from this sloppy video. And you know, just from the cell of your lungs, if I don't get this right, that's just, you guys can just kill me. I mean, kill me in the comments, not real life. I want to live. When your lung walls are damaged, the bacteria in your body can infect your lungs, and those can cause you to die. And I think, yeah, so let's have a little bit of fun with this. Let's say that actually, after, let's say that if after the first time the movement control order is passed, it reduces the amount of infectivity by 0.25. Oh, crazy amount. That's the first day, and then you see there's not really that much change, but let's see. Yeah, actually, well, let's plot that on the graph. Let's see here. Wait, let's try something. Yeah. Okay, so what do you use? The bar chart. Okay, let's see. So with that much of a, whoa, that's messed up. Okay, so I don't know what happens here. Oh wow, okay, that's a sharp decline there. I don't know why it's like that. Let's see. What the? Okay. What the? Oh, okay. Yeah, that's messed up here. Let's see here. Yeah, as you can tell, this is not a video I planned really well. I just wanted to do a little discussion with how bad the coronavirus can spread and how bad we can make it if we're not careful. So yeah, wait. Let me just give it a fixed value here, just so we can have uh, a better look at these numbers, so that we don't have like a messed up jumble of uh, a messed up jumble of digits. Oh wow, okay. Okay, yeah, okay, that makes sense. Yep. Alright. Alright. So yeah. That's how much we can reduce it. Alright. From the graph before, you might have expected that. Oh, and look at that. The model here is kind of messed up since the initial values are fucked up, but I think it's acceptable because we don't really know all of the cases, because people don't know if they are infected but just not showing symptoms, so they just go out and infect more people with it. This is an acceptable number. Wait a minute, yeah, let's check my number here. Oh, 19 minutes already. God damn. Okay, anyone who's been watching this, I thank you so much for going through with this exploration of the data here. But yeah, I think my data is pretty much correct, and by the end of the movement control order, if everything is right, we'll get like 72,000 people infected. But let's try to match the data here. Let's actually try to match the data. So it starts to split off here. That's this part. So let's try raising it up to here. Yeah, okay, so 0.25, let's say it's reduced from 0.05 946,652 0.5 minus 0.05. That's not enough. We need to go a little bit more on the reduction side. Let's go 0.15 for 50 607.5. Oh, is it 0.25 by half? Oh, by half is still not, it's not enough. Okay. Yeah, okay, still not enough. 0. I think 45, yeah, 472. Oh yeah, that's too much. 35 570. Okay, there we go. That's a much more sensible number. I think starting from there we can have a 0.15 infection rate, and yeah, it starts to tread through, but I think that's a bit too much. Let's see, 0.35, 0.31. Let's see, a 0.31 reduction. Yep, okay. Oh yeah, that's pretty acceptable. So starting from there, you can see if the movement controller reduces the amount of infection by 0.025, we should have a peak of around 637 people by the 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. So on the 8th day of the quarantine, we'll have the peak amount of people being infected, which is 167 167 people, and then yeah, that's pretty much the peak if everything goes well and if my model data is correct, because this is just me messing around with the data, and it's not even reliable data, it's just reported cases. So take this with a grain of salt. I'm sorry if this is not scientific enough for you. And by the end of the quarantine, the movement control letter, we will have around 24 people infected. Yeah. So this is, starting from here, the data is kind of wonky because we have negative spread rates, meaning people who heal is faster than the people who are getting infected, so it's kind of wonky starting from there. So yeah, let's clean it up a little bit, and let's make a chart. So the no, that's not what I want. Line chart, yeah, there we go. So starts going up and it goes down, a really sharp down right here, and I don't know, this chart looks a bit weird to me. I don't know what the x-axis stands for. The data is a bit weird. I don't see any zeros here. Let me figure it out, guys. Just wait. Let's delete this thing. Yeah. Oh, okay. We started 200.3.4, 758, Failure 1450. Wait, the failures are going up, but why isn't it represented? This is odd. Huh. Starts when I'm using the fixed data. It's just not accepting it as actual data points. I think it's because of the fix. Oh well, let's not do that fixed amount because you guys are formula contains error. Oh, okay. Yeah, let's drag this down now. Yeah, it's a bit. Yeah, there's no 0.1624 people of a person, but you know what I mean. And the data is pretty much, you guys seen the data already, so let's just see what the chart looks like. So yeah, looks like a pretty normal uh, spread rate if you have ever seen any virus spread rate. It just goes up, 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 and decays slowly. And this is pretty much what my prediction is. A peak of 1,470 people. Wait, 1,600. Yeah, 1,600 people around there. Peak will happen on the 26th of March if the movement control order is going well. And I do not suspect that that is the case. So let's adjust the data to reduce the amount of infection, to reduce the infectivity by 0.15 instead. And I think that's more realistic, I think. And alright, so. Oh, okay, no. No, no, no. Okay. Oh, nope. Forgot the things I need to do. So here is the actual infection, maybe something that will be closer to reality in Malaysia. We will not be as bad as Italy. There's one thing for certain, based on my mathematical model here. Will be better, but not by much, I must say. Quite disappointing. Oh, come on. Yes. Oh, that's annoying. That's fine. Okay. Let's not bother with that now. Just let's see here. It does predict 100 more people than the real data, but that's fine. Plus minus 100 is okay in my scientific eye here. So yeah. Anyways, oh wow, okay. It's trading pretty good, but yeah, that's fine. We'll just see here. We'll just see if my prediction holds true. My purely mathematical prediction. Of course, we don't know how many people might heal up before then. Yeah. I don't think I have the coronavirus, but if I do, what can you do about it? So yeah, this is my prediction of what the coronavirus will do in the 14 days of our, in these 14 days. The peak will be around 2,573, and it actually will be continuing to rise until the 14th day, and then it actually drops on the 15th day. So even though it drops at the 15th day, you guys need to be careful when the movement control order is actually lifted. Do not think that the 15th day is freedom. I cannot stress this enough. The problem with this virus is how infectious it is, not how much it can kill. It can kill you, but not by itself. It needs you to be weak. So yeah, and if it doesn't kill you, think about your loved ones, your parents, your grandparents, your neighbors, your old neighbors particularly, and your old lecturers, your sugar daddies and your sugar mommies. I don't know what kind of relationship you guys have, so just be careful out there, yeah. And with that, I'm kind of out, and let's just see how good my model is when we compare it to the model that's so wait, what is this? 900, 1030, 1180, and 1310. Yeah, okay. So yeah, what the? Okay, messed up here. Let's see as one final demonstration of how accurate my data is, my model data is. Let's see how it stacks up with the actual data and the simplified data. So here, yeah, it syncs up pretty well. In the beginning, yeah, okay, you know, we only use the same early point, pretty much all three threads in the same direction and same growth rate. So please, if you want to see this as a reality, and just to make sure you guys realize that that's not the yeah, this is how it will look like throughout the 14 days. This is how it will look like until the 12th of April, the 1 week after. Yeah, so again, stay in your homes, please, and stay safe. Thanks, thanks, guys. I have a weird accent, but what can you do? What can you do?